Hello, I'm James Ayrson, and my experiment is about exhaust gas heat recovery. In the world today, there are over 1 billion cars. However, these cars throw 5 kilowatts of heat out of the exhaust. But in the engine compartment, there's an alternator which is using 500 watts just in there. So what could you achieve if you could use the waste heat from the exhaust at 10% efficiency to replace the alternator? This is the equipment for the experiment. We'll burn this solid fuel to simulate the exhaust from the car. The boiler here will simulate the water jacket surrounding the exhaust. Steam from this will then be taken to the cylinder, powering the flywheel to power this dynamo. A load will then be put on it using this resistance wire, and the power produced will be measured using this multimeter. Throughout the experiment, all the equipment was weighed to calculate the fuel usage rate and steam production rate. The scales have just been zeroed, so there's no systematic errors creeping in. Here we see the engine running at a loaded rate, producing about 1 volt on the multimeter. This is an open loop system, so steam is merely wasted to the environment. It was noticed that only 0.1% of the energy in the boiler is taken to the dynamo. Of the 130 watts absorbed by the boiler, 124 watts is released as steam. If that energy could be recovered, only 6 watts of external energy would need to be put in. However, the dynamo only produces 0.07 watts. This is because the dynamo and flywheel are not optimised. An optimised system could produce double that. This would present a 1.4% saving on fuel in cars, the equivalent of 1.4 million tonnes of oil or 3.2 million tonnes of carbon dioxide saved per year.